Welcome back to physics online session. So we were discussing about that applications of the Boyle's law. So already we come to know that about that Boyle's law and as well as application of the Boyle's law. In case of Boyle's law, we come to know that relation between pressure and volume. Now I can consider that what is the relation between temperature and volume as well as the temperature and pressure. In order to understand such thing, so we will study about that Charles law here. So this Charles law is understand by two way here. For example, I can consider that Charles law by constant pressure if that pressure of the given gas is constant, like that. ಹೌದ್ರಿ? ಸೊ ನಾನು ಒಂದು ಕಂಟೈನರ್ ನಲ್ಲಿ ಗ್ಯಾಸ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. ಆ ಗ್ಯಾಸಿನ ಪ್ರೆಷರ್ ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ ರೀ? ಕಾನ್ಸ್ಟೆಂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. ಇಫ್ ದಟ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಗ್ಯಾಸ್ is constant, ಆ ಗ್ಯಾಸಿನ ಪ್ರೆಷರ್ ಏನಿದೆ ರೀ? ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ ರೀ. Now I will heat up the gas. So if I heat up the gas, how that temperature means how that volume is going to changes if I increase the temperature, I need to understand. So in order to understand such aspect, so we'll study about that Charles law here. So in this Charles law, we can study this Charles law by keeping that constant pressure and as well as constant volume here. Charles law at constant pressure here. So ಇಲ್ಲಿ ಆ ಗ್ಯಾಸಿನ ಪ್ರೆಷರ್ ಏನು ಮಾಡ್ತೀನಿ ರೀ? ಕಾನ್ಸ್ಟೆಂಟ್ ಇಡ್ತೀನಿ ರೀ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ here in this container I will take that gas here, some amount of gas here. Pressure of the gas is constant here. At constant pressure, that word itself it indicates that. How to define that Charles law here? At constant pressure, at constant pressure, so pressure of the gas is constant. At constant pressure, the volume of given mass of gas the volume of given mass of gas is directly proportional to temperature. So look at here what I said here. At constant pressure, if that pressure of the gas is constant, so now if I heat up this gas, means temperature is increases. As the temperature of the gas increases, means volume of the gas is also increases here. At constant pressure, volume of given mass of gas is directly proportional to temperature on Kelvin scale. We can consider the temperature Kelvin scale here. Look at here, from this statement we come to know that volume is directly proportional to temperature. ಇದರ ಅರ್ಥ ಏನ್ರಿ? ಇಲ್ಲಿ ಗ್ಯಾಸಿನ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆದಂಗೆಲ್ಲ ಗ್ಯಾಸಿನ ವಾಲ್ಯೂಮ್ ಕೂಡ ಏನಾಗುತ್ತೆ? ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ವಾಲ್ಯೂಮ್ is directly proportional to temperature, or volume is equal to K into T. So if I remove that proportionality sign, I will get that proportionality constant. ಹೌದ್ರಿ? Look at here, I will take to left side. V by T is equal to constant. So look at here, volume of the gas is directly proportional to temperature if you heat up the gas by constant pressure. So gas in a constant pressure nalli heat madidagri allenagutte alli. So as the temperature of the gas increases, gas in temperature increase adangella gas in a volume nu kuda enagutte increase agutte. What is the connecting formula here? V by T is equal to constant, or V1 by T1 is equal to V2 by T2 we can consider. So this is about Charles law at constant pressure. Now we can consider that Charles law at constant volume also we can consider. So we can understand that relation between volume and temperature. Already I come to know that volume and temperature are directly proportional. Now we can consider that Charles law at constant volume. Charles law at constant volume here. So look at here, I will consider gas in a container. ಒಂದು ಕಂಟೈನರ್ ನಲ್ಲಿ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ ರೀ? I will consider that gas and volume of the gas is constant. ಇವಾಗ ಏನನ್ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಡ್ತೀನಿ ರೀ, volume of the gas, I will keep it constant here. At constant volume, the pressure of given mass of gas is, so at particular mass here, the pressure of given mass of gas, the pressure of given mass of gas is directly proportional to temperature. Again, pressure of given mass of gas is directly proportional to temperature on Kelvin scale we can consider. Look at here. So ನಾನು ಒಂದು ಕಂಟೈನರ್ ನಲ್ಲಿ ಗ್ಯಾಸ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ ರೀ. ಆ ಗ್ಯಾಸ್ ನ ವಾಲ್ಯೂಮ್ ಏನಂತ ತಗೊಂತೀನಿ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇಡ್ತೀನಿ. ವಾಲ್ಯೂಮ್ ಐ ಆಮ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಚೇಂಜಸ್. ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ಗ್ಯಾಸ್ ಏನಿದೆ ಇಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. ಅಗೇನ್ ಐ ವಿಲ್ ಹೀಟ್ ಅಪ್ ದ ಗ್ಯಾಸ್. ಮತ್ತೆ ಗ್ಯಾಸ್ಗೆ ಏನು ಮಾಡ್ತೀನಿ ರೀ, ಹೀಟನ್ನು ಪ್ರೊವೈಡ್ ಮಾಡ್ತೀನಿ. ಆಸ್ ಐ ಪ್ರೊವೈಡ್ ಹೀಟ್ ಮೀನ್ಸ್ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಗ್ಯಾಸ್ ಈಸ್ ಗೋಸ್ ಆನ್ ಇನ್ಕ್ರೀಸಸ್. ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಗ್ಯಾಸ್ ಏನಾಗುತ್ತೆ ರೀ, ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಇಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಏನಂತ ಇದೆ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. ಸೊ ವಾಲ್ಯೂಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ದಾಗ್ರಿ ವಾಟ್ ಎವರ್ ದ ಗ್ಯಾಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ದೇರ್, ದೀಸ್ ಗ್ಯಾಸ್ ಪಾರ್ಟಿಕಲ್ ಗೇನ್ಸ್ ದ ಎನರ್ಜಿ. ಈ ಗ್ಯಾಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಗಳು ಏನಾಗ್ತಾವ್ರಿ, ಇಟ್ ವಿಲ್ ಗೇನ್ ದ ಎನರ್ಜಿ ಅಂಡ್ ಇಟ್ಸ್ ಪ್ರೆಷರ್ ಈಸ್ ಗೋಸ್ ಆನ್ ಇನ್ಕ್ರೀಸಸ್. ಆ ಗ್ಯಾಸಿನ ಪ್ರೆಷರ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಹಿಯರ್ ವಾಲ್ಯೂಮ್ ಈಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಇಲ್ಲಿ ಏನಿದೆ ರೀ, ವಾಲ್ಯೂಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ ರೀ. ಸೊ ವಾಲ್ಯೂಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ ರೀ, ಪ್ರೆಷರ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಗ್ಯಾಸಿನ ಪ್ರೆಷರು ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಲುಕ್ ಅಟ್ ಹಿಯರ್, ಅಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ pressure of the given mass of gas is directly proportional to temperature. ಅಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ಇದ್ದಾಗ ಗ್ಯಾಸಿನ ಪ್ರೆಷರ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಪ್ರೆಷರ್ is goes on increases. You can consider or P is equal to K into T or P by T is equal to K, where K we can consider as constant. K ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಕಾನ್ಸ್ಟೆಂಟ್ we can consider, or P1 by T1 is equal to P2 by T2. So this is about Charles law at constant volume and this is about Charles law at constant pressure we can consider. So look at here, in both the cases I can understand that what is the relation between volume and temperature. Here relation between pressure and temperature. ನೀವು ಇಲ್ಲಿ ಒಂದು ಗ್ಯಾಸನ್ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ನಲ್ಲಿ ಹೀಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಅಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆದಂಗೆಲ್ಲ ಗ್ಯಾಸಿನ ವಾಲ್ಯೂಮ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ರೀ. ಸೊ ಇಲ್ಲಿ ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿರಿ, ಗ್ಯಾಸಿನ ವಾಲ್ಯೂಮ್ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಟೇನ್ರಿ. ಸೊ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ಗ್ಯಾಸ್, ಸ್ಪೇಸ್ ಯು ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್. ಇಲ್ಲಿ ಗ್ಯಾಸಿನ ವಾಲ್ಯೂಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ದಾಗ್ರಿ, ಇಫ್ ಯು ಇನ್ಕ್ರೀಸ್ ದ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಗ್ಯಾಸ್, ಆ ಗ್ಯಾಸಿನ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆದ್ರೆ ಗ್ಯಾಸಿನ ಪ್ರೆಷರ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಪ್ರೆಷರ್ ಆಫ್ ದ ಗ್ಯಾಸ್ ಇಸ್ ಆಲ್ಸೋ ಇನ್ಕ್ರೀಸಸ್. ಸೊ ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ಚಾರ್ಲ್ಸ್ ಲಾ ಅಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ and as well as constant. Okay, so we'll solve some numericals on this Charles law. Look at here, an ideal gas at 13 degrees Celsius. Ideal gas is there. What do you mean by ideal gas? The gas which obeys Boyle's law at all temperature and pressure we can consider as ideal gas. Here an ideal gas at 13 degrees Celsius is heated double to its volume at constant pressure. So on the ideal gas ಗೆ ಟೆಂಪರೇಚರ್ ನ ಎಷ್ಟು ಪ್ರೊವೈಡ್ ಮಾಡ್ತಿದ್ದೇನೆ, temperature is 13 degrees Celsius. So I will heat up that gas double to its volume at constant pressure. Initial volume ಏನಂತ ತಗೋರಿ, initial volume is V, double its volume ಏನಂತ ಆಗುತ್ತೆ ಇಲ್ಲಿ 2 times of V at constant pressure here. So at constant pressure find the final temperature of the gas. Which thing I need to determine here? Final temperature of the gas I want to find out here. Look at here, I will heat up the gas by constant pressure. So by constant pressure ಅಂದ್ರೆ ಯಾವ್ದು ತಗೋಬೇಕ್ರಿ, Charles law at constant pressure. Here what is the connecting formula for Charles law at constant pressure? Here V1 by T1 is equal to V2 by T2 here. Now I said that in case of Charles law, so at Charles law at constant pressure, what I said about the definition here, at constant pressure volume of given mass of gas is directly proportional to temperature on Kelvin scale. ಇಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಯಾವ್ದು ಕೊಟ್ಟಿದ್ದಾರೆ, ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಫಸ್ಟ್ ಐ ಕ್ಯಾನ್ ಕನ್ವರ್ಟ್ ದಿಸ್ ಟೆಂಪರೇಚರ್ ಫ್ರಮ್ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಟು Kelvin here. This is the formula, right? Look at here, 13 plus of 273 286 Kelvin. What is the temperature on the Kelvin scale here? 13 degrees Celsius is equal to 286 Kelvin here. Now they mention that initial volume is V. Initial volume I can consider as V. Temperature is 286, right? It is equal V2, what they given, 2 times of V divided by T2. I have to find out what, suppose I have to find out here, I have to find out T2 value. V term will getting cancel out here. Okay, look at here, T2 is equal to 2 into 286. You can, so T2 value is how much, 2 into 286. Okay, so 572 Kelvin. What is the temperature here? So temperature is 572 Kelvin. So in terms of degree Celsius, so they given degree Celsius, first I have to take it in Kelvin. Again, what's the temperature in case of degree Celsius? T2 plus of 273. So T2 is how much, 572, right, minus of 273, it is equal to T2. So temperature in terms of degree Celsius, again I am converting here. So T2 is equal to sorry 572 minus of 273. So this is about 572 minus of 273. So we will get it as 992. So 299 degree Celsius. What about the temperature here? Temperature is 299. Keeping the volume constant. So here volume of the gas is constant. Keeping that volume constant. So volume constant and pressure constant means directly you can think that it is about Charles' law. Keeping that volume constant, the pressure of the gas is increased by 10% here. How much percentage that pressure of the gas is increases here? Pressure of the gas is increases by 10% of its original value by increasing the temperature from 27 degrees Celsius. Find the final temperature. Look at here. So question meaning ಏನು really? So ಒಂದು gas ಇದೆ ರೀ, ಗ್ಯಾಸಿನ ವಾಲ್ಯೂಮ್ ಏನು ಮಾಡಿದೀವಿ ರೀ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಟಿದೆ. The pressure of given gas is increases by 10% of its original value here. For example, original value of the means original pressure of the gas is P. I have to consider. So ali original pressure eshtide ri, P anta ide ri. How much percentage that pressure is increases here? So percentage ಎಷ್ಟು increase ಆಗಿದೆ ರಿ, 10%. How much percentage pressure of the gas is increases here? 10%. Initial temperature of the gas is 27 degrees Celsius. Initial temperature eshtiದೆ ರಿ, so 27 degrees Celsius ಇದೆ ರಿ. Final temperature of the gas is, so again I have to find out that T2 value. Question meaning ಏನಾಯ್ತು ರಿ, ಗ್ಯಾಸಿನ ಟೆಂಪರೇಚರು 27 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇದ್ದಾಗ್ರಿ ಇದರ ಪ್ರೆಷರ್ ಪಿ ಅಂತ ಇದೆ ಅಂತ ಅನ್ಕೊಡಿ. ನಾನು ನಿಜವಾಗ್ರಿ ಗ್ಯಾಸಿನ ಪ್ರೆಷರು 10% ಇನ್ಕ್ರೀಸ್ ಆಯ್ತು. ಹೌ ಮಚ್ ಪರ್ಸೆಂಟೇಜ್ ದಟ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಗ್ಯಾಸ್ ಇನ್ಕ್ರೀಸಸ್ ಹಿಯರ್? ಗ್ಯಾಸಿನ ಪ್ರೆಷರು 10% ಇನ್ಕ್ರೀಸ್ ಆಯ್ತಂದ್ರೆ ಎಷ್ಟು ಟೆಂಪರೇಚರ್ಗೆ 10% ನಷ್ಟು ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಆಯ್ತಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕ್ರಿ. ಸೊ ಫಸ್ಟ್ ಅಗೇನ್ temperature in terms of degree Celsius they given, I can convert in terms of Kelvin here. 27 plus of 273, temperature is 300 Kelvin. Temperature ಆಯ್ತು ಇಲ್ಲಿ 300 Kelvin ಅಂತ ಆಯ್ತು. ಹೌದು. ಸೊ ಇವಾಗ ಇನಿಷಿಯಲ್ ಪ್ರೆಷರ್ ಪಿ ಅಂತ ಇದೆ. ಸೊ ಪ್ರೆಷರ್ ಎಷ್ಟು ಪರ್ಸೆಂಟೇಜ್ ಇನ್ಕ್ರೀಸ್ ಆಯ್ತು? 10%. ಹಂಗಂದ್ರೆ ಫೈನಲ್ ಪ್ರೆಷರ್ ಏನಾಯ್ತು ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕ್ರಿ. ಐ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ದಟ್ ಫೈನಲ್ pressure value. Which thing I need to find out here? Final pressure value I need to find out here. What is the formula? Percentage. So change in pressure in terms of percentage is P2 by P1 minus of 1 into 100. ಈ ತರ ಫಾರ್ಮುಲಾ ತಗೊಂತೀರಿ ಜನರಲ್ ಆಗಿ. ಇಲ್ಲಿ ಪ್ರೆಷರ್ ಎಷ್ಟು ಪರ್ಸೆಂಟೇಜ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ರೀ? 10% ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ರೀ. P2 ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕ್ರಿ. P1 ವ್ಯಾಲ್ಯೂನ ಅಂತ ತಗೊಂತೀನಿ ರೀ ಜನರಲ್ ಆಗಿ P ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ. 21 divided by 100 here. ಹೌದ್ರಿ? ಅಥವಾ ಇದನ್ನ 10 is equal to P2 LCM ತಗೊಂಡು minus of P divided by P into 100 here. So ಏನಂತ ತಗೋಬೋದ್ರಲ್ಲಿ 10P it is equal to P2 minus of P. So 100 in ikkada left side ತಗೋಬಹುದ್ರಿ. Did you get my point? Look at here, 10p by 100 minus p, if it goes to left side, plus p. P2 value is this much, 100p plus of 10p, 110p divided by 100, it is equal to P2. I got that P2 value here. Now from that Charles law, they mentioned that constant volume, at constant volume P1 by T1 is equal to P2 by T2. So if that pressure is increases by 10% means final pressure I need to find out. ಏನನ್ನ find out ಮಾಡ್ಕೋಬೇಕು ಇಲ್ಲಿ ರೀ, final pressure ಎಷ್ಟು ಐತ್ರಿ final pressure ರೀ, 110p by 100 we can consider. ಹೌದ್ರಿ, ಅಥವಾ ಡೈರೆಕ್ಟ್ ಆಗಿದ್ರು ಬರ್ಕೋಬೋದ್ರಿ. 10% ಇನ್ಕ್ರೀಸ್ ಆಯ್ತು ಅಂದ್ರೆ ಏನು ತಗೋಬೋದ್ರಿ, ಸೊ 100% ಮ್ಯಾಕ್ಸಿಮಮ್ ತಗೊಂಡ್ರೆ 10% ಇನ್ಕ್ರೀಸ್ ಆದ್ರೆ 110 divided by 100 ಡೈರೆಕ್ಟ್ ಆಗಿದ್ರು ತಗೋಬೋದ್ರಿ, ಅದ್ರ ಫಾರ್ಮುಲಾ ಇಂದನಾದ್ರೂ ತಗೋಬಹುದು. Look at here, P1 value ಏನಂತ ತಗೊಂಡಿದ್ದೀನಿ ರೀ, P I consider, T1 value 300 Kelvin, P2 value is how much, 100p divided by 110p divided by 100 here into T2. So T2 value now find out ಮಾಡ್ಕೋಬೇಕ್ರಿ ನಾನು ಇಲ್ಲಿ. Look at here, so P term will getting cancel out, T2 is equal to 110 into 300 divided by 100 here. Okay. Look at here, 110 into 3, 11 into 3, 33. So 10 is there, 330 Kelvin. What is the temperature here? Temperature is 330 Kelvin. So T2 plus of 273, 330, it is equal to T2 plus of 273, 330 minus of 273, it is equal to T2 we can consider again in degree Celsius. T2 is equal to 330 minus of 273. So that is 57 degree Celsius. So what is the temperature in, so final temperature here. So in order to increase the pressure by 10%, how much temperature is changes here, final temperature becomes 57 degree